Well, good afternoon, class. It's Professor Boyle again. This is the lab experiment on Archimedes principle. And I know that you can't be here to actually do it, but you would definitely be able to see what I'm doing in this particular experiment. So on page 21 of the lab manual, and I need to read from the lab manual and then also show you what I'm going to do. So it says here, Archimedes principle. It says we need an overflow can, and this thing is called an overflow can. I'm sorry, this big can is called the overflow can, right there. That's called an overflow can. And I need another can, this can is called a catch can, like that. And this device right here is called a triple beam balance to weigh things. All right? Now step one, it says we wanted to attach a string to a 500 gram aluminum cylinder. Well, I did attach the string to these cylinders, but that was not 500 grams, so I wrote on the board here. Step one, weight of the aluminum cylinders in gram force. Now we're going to use gram force rather than newtons because it's easier to do the calculations. So that came out to be 223 gram force, GMF for gram force. Then step two was to fill an overflow can to the top with water, which I did, and my assistant could look at this now. Okay, here's the overflow can. I filled it with water, and then it said I very slowly allowed the weights to go into the water, and as they went into the water, they pushed water out of the way, and so it came out through this overflow area here into the catch can. And so we caught the water that came out, okay? And then it says here, slowly lower the aluminum cylinder into the overflow can and catch the water in the overflow can, called a catch can. Take note of the reading on the spring scale. So that is step two. What happens is you tend to lose weight in that particular case. So where before it was 223 gram force, now it's going to be 144 GMF, gram force. So you lose weight. And actually, this is something that you all understand because if you go into a swimming pool, you know as you go into the pool, you feel lighter because you're pushing water out of the way. You push the water out of the way, the water pushes back, and you feel lighter, and you can float. All right? So that came out to be about 144 gram force. That's the spring scale pulling up. And then the buoyant force, or the buoyant force, I'm from Philadelphia, so I say buoyant, but I think it's buoyant is the correct way of saying it, comes out to be 223 gram force minus 144 gram force, and that came out to be 79 gram force. Now, to give you an example of what I'm talking about, if I go into a pool, what happens is I tend to lose weight. I weigh, I'm going to say on a good day, 150 pounds. I get in the pool, and now I only weigh about maybe 100 pounds. So therefore, the water's pushing up on me with a force of 50 pounds. 150 minus 100 is 50 pounds of buoyant force. That's the buoyant force. That's the force the water's exerting on me. So that's actually step two. Now step three, and I'm going to read from the book again. Determine the buoyant force acting on the aluminum cylinder by subtracting, let me say that again. Determine the buoyant force acting on the aluminum cylinder by subtracting the reading in step two from the weight of the cylinder found in step one. Well, that's going to be equal to 223, which was the original weight, 144, it's lost weight, so now it's only 144. So therefore the lost weight is 79 GMF, and that's actually the buoyant force that's been acting on the cylinder. Just like if you go in the water, if you weigh 150 pounds, and in the water you only weigh 100 pounds, that means that you've lost 50 pounds of weight, and that's the buoyant force. All right? And finally now, the fourth step is to use a triple beam balance. I'm using a triple beam balance to wedge the catch can plus water. Well, when I did that, the weight of the catch can plus the water came out to be, and I'm going to show you that right now, right here. All right? That came out to be about 115 GMF. Now, what that means is that that. Now, what I have to do though is to subtract off the weight of the catch can, just to get the weight of the water. So what happens is the catch can was 35 GMF, gram force, subtract that from 115 gram force, and you get 80 gram force, which is the buoyant force according to that calculation. Now, you can look at me again now. I'm looking at my assistant, who happens to be the woman of my dreams, also known as my wife. And she's saying, don't say that about me, but you are. She's the brains in this outfit. Now, step 5 here, it says, according to Archimedes' principle, the buoyant force, notes in the book, you have to look on page 21 of the book. According to Archimedes' principle, the buoyant force equals the weight of the fluid displaced. The buoyant force equals the weight of the fluid displaced. So what would happen here is that turned about 79, that's how much weight you lost, and the water that we found that was displaced was 80. So they're a very close approximation, they're about the same, and that's Archimedes' principle. Now, one more thing about Archimedes, he lived in a place called Syracuse in Sicily. And he did all these rather famous experiments, including one which involved a job given to him by the king, King Hiero II. And the king asked him to show that a crown that they had made was made of pure gold, because he thought maybe the jewelers had cheated him. So what Archimedes did was he went home, he got in his bathtub, sat down, and realized that actually he displaced water and he lost weight. And that was the inspiration for Archimedes' principle. And actually Archimedes, unfortunately, the Romans went into Syracuse, and they went into his room, and a Roman soldier, being told not to hurt him, killed him. And that was the ending of Archimedes' life. Rather famous scientist, and really a tragedy what happened to Archimedes. And that is the end of part 1. Now you want me to get up here and explain it to them again?
Just point to each step.
Just as a review. The first step was the weight of the aluminum cylinders in GMF, and that came out to be 223. Then step 2, what we did was we put the cylinders in water. The new weight came out to be 144 GMF, they've lost weight. And what happened was when the cylinders went into the water, it pushed water out of the way and it was caught in this can called the catch can. Now, to determine the buoyant force then acting on the cylinders, what you do is you take the true weight was 223, you subtract from that the new weight, which is 144, which means the buoyant force was 79 GMF, gram force. Now, the weight of the catch can plus water, that's what we did next, that came out to be 115 GMF. But we have to subtract off the weight of the catch can, which was 35 GMF, and when you subtract 35 from 115, that comes out to be 80, and this came out to be really close to the buoyant force we calculated earlier. And that's the end of that segment.